Hello, my name is Alan, and welcome to episode 2 of how to use Blender and Python to make an animation that's better than AI, what AI can do. So, if you haven't watched lesson 1, you should watch it, but if you have no time, I'll briefly go over what we did. So first we created some defined functions to create new functions. So we have create cylinder, which I use to create my cylinders. And we have create valve with barrier, which creates the little valves using this create cylinder. We have setup collapse animations, which uses create valve with barrier, which also uses create cylinder to create this this tank. And then we have setup scene, which basically sets the background things like the floor. Then down here we just run all of this defined functions to create our scene. So the final result was our basic model and also a little animation showing our little barrier for the water valve just going away, letting the water come out, but we haven't animated that yet. So in this episode we're going to animate this the implode the tank imploding. So we're gonna start down here, line 47, and we're gonna write another define function called add cloth simulation. What is a cloth simulation? It's just the kind of simulation thing we use make to to make the animation. So the parameters are obj pressure start, pressure end, frame start, and frame end. And here we're going to add a comment. Add cloth simulation to an object obj with pressure here and pinning. We're going to introduce pinning later. So the first line we're going to write is modify add type is equal to cloth. So we just apply the cloth simulation to the object, which is obj. So the cloth mod is equal to obj dot modifiers. Basically what this does is that it takes all the modifiers and gets the last one, which is basically the cloth simulation. Okay, next thing we're going to do is enable pressure settings. Okay, so the pressure settings, how we're going to write this is cloth mod dot settings, and then we're going to copy this because we're going to write this a lot in this section. So the first line is use pressure, and we're going to set that to true because we are using pressure. Paste uniform pressure force. which is equal to 0. The next we're gonna write keyframe insert data path uniform pressure force, and then frame equals 1. And it's not insert, it's insert, so I'm going to delete that W. Alright, so what this does is that it just sets the uniform pressure force to 0 starting from frame 1 because we don't want then to collapse, the thing to collapse at the beginning. Okay, next paste uniform pressure force. It's going to be pressure start. And then we're going to add a keyframe. Insert data path is equal to uniform pressure force frame for this one is equal to frame start. So it's just the frame we're using. We set up here. Uniform pressure force pressure and keyframe insert is data path is equal to uniform pressure force. Frame is equal to frame end. So we're also defining that. Alright, so we're done enabling process settings. Now you're going to set the collision for this object so it doesn't phase through like the floor or something. So we're going to write bpy.ops.modifier underscore add and type is equal to collision. Alright, so we're done with this new defined function. We're going to go down to setup collapse simulation and I'm going to add something new here. So over here in between the air valve code and the create cylinder for the big tank code, we're going to write in a comment subdivide for better physics simulation, because that's what you're doing. Okay, so we're going to first, so we're gonna edit it, like, so we're gonna first set it into edit mode. Then we're going to write this code bpy.apps.mesh.subdivide number cuts equals 5. So basically what this code does, what this value over here does, is that the higher this number is, the slower the simulation will be, but the simulation is going to be more even. So we're going to need to find a number that kind of fits perfectly with both of our code. And then the last line is object mode slash back to object mode. Okay, I forgot to add the dot here. Okay, now we're going to go down a few lines, and we're going to create a cloth simulation. Not create, we're going to add the simulation. We would apply it from last time. So add cloth simulation. And here it's gonna be tank pressure start is equal to 0.0 pressure and is equal to -1. Frame start is equal to 80 frame and is equal to 90. So our tank is going to be the OBJ, so that's what's going to get imploded. It's the big tank. So the starting pressure is 0, then it's going to go -1, so it's like negative pressure. Frame of start is 80, so between frames 80 and 90 is where the implosion animation is going to happen. Okay, now we go down here where we're going to add some gravity. At the setup scene place, we're going to add some gravity. So by.context.scene.gravity, which means that gravity. So 0 for the x-axis, 0 for the y-axis, negative 9.81 for the y-axis. Basically, it's like real world gravity. If you drop something down from a height every second, it'll drop faster by 9.81 meters per second. So basically 9.8 meters per second. And now, after this, add floor. We're going to add modifier add. So we add collision to this. And this is what we get. So you can see the tank because of gravity, and we remember in the last episode we made this tank a bit above the floor, and we set collision for the floor and the tank. The tank is going down and bouncing back up while also jiggling around. which is what we want because it's kind of like our simulation, but not exactly. So, to fix this, we're going to add a bit more code. So we're going to go back to scripting, and we're going to go back to line 47 where I had this defined function. We're going to kick that out of line 47, and then line 47 we're going to add a defined function. Basically we just kicked out this defined function to create another defined function. So this defined function is going to be called create vertex group. WJ group name, vertices to include. And up here it's going to be create a vertex group and assign specified vertices to it. Okay, here mode set mode is equal to edit. So we're going to set this to edit mode. Yeah, so this function is going to create a group of vertices, which is what you can see from the title. But I'm going to tell you again anyway. And so after we set to edit, we're going to add a bit of comments here to help us remember what these are for. So first set to edit mode. Given this comment right, so that you can do something about the object. You will see what the do is later. For example, to create a new vertex group. Alright, so we're going to type vj is equal to obj dot vertex group start new. The name is going to be group name. So we're gonna that's gonna be one of the parameters. How we're gonna write the group name when we run this define function. Now switching back to object mode because we can't leave it edit mode. So we're going to mode set back to object mode. Okay. Now that we're done with this line, we go down a few lines. We can type for IDX and vertices to include. vg.add index 1.0 replace, and then over here we're just going to return VG. Okay, so we're done with this define function. Now we're going to go back to the define class animation we wrote a bit earlier, and over here we're going to assign the vertex group, assign a vertex group for pinned vertices. Cloth mod is settings.vertex group mass is equal to pinned vertices. So that's the name for the vertex group for pinned vertices. And if you notice, pinning, we've introduced pinning. What is pinning? Pinning is basically just holding down some of these vertices so that the big tank would not fly up, do the correct animation, instead of just bouncing up and down like it is now. So what this line does is basically it tells Blender there's a group of vertices called pinned vertices, and you don't apply the cloth simulation to them. So now we have to actually create vertices, this group of vertices. So down here we add a comment that says create a vertex group for pinning the bottom and top vertices. And then we say bottom top vertices is equal to bracket v dot index for v and tank dot data dot vertices. So what this does is that it takes a point and it puts them on all the vertices on the tank. And V, and also it puts these points in the list. And V is every index in the list, so it represents that. And then we type if v.co.c is smaller than negative 2.2, or v.co.c is bigger than 2.2. So what V is, what co is just means coordinate. Z is the Z coordinate, so the up down part on the model. So we need the Z, so we pin the points that are below the Z coordinate negative 2.2 and above the coordinate 2.2. Why 2.2? Well, I don't really know. I tried different points, and 2.2 got the best result. So that's why I chose 2.2. Now, this next line, right, create vertex group. That's the define function we did earlier. Tank pinned vertices and bottom top vertices. And that is it. So if you go to animation, look, you can see that instead of going up and down, the middle parts collapse inward, and that's the animation that we want. You can so now our model is the barrier flips open, and then boom, the tank implodes. So that's what we're doing for this lesson. Next lesson, we're going to make the water animation, so the water spilling out of this valve. Bye.